In this lesson, we'll still be looking at sequences, but we'll be creating what are called recursion formulas. So instead of using the arithmetic and geometric sequence formula, we will be coming up with a recursive formula, and that's when the previous term is used to calculate the next one. If you've taken computer science or done any programming, you may be familiar with what recursion means, so you may be a little more comfortable with this lesson. Now, taking a look at this first example, my sequence is 2, 6, 10, 14. Now, this is clearly an arithmetic sequence with an A value of 2 and a D value of 4 because we're adding 4 each time. Now, that would give me a formula that term n is equal to, and you should be comfortable with the formula by now, 2 plus n minus 1 times 4 would be my general equation. Now, for a recursive formula, instead of coming up with this general formula right here, what I want to do is I want to come up with a formula for term n, but it has to use term n minus 1. So if term n is the term that we're calculating, term n minus 1 is the previous term. Now, if you think about it, let's say that I'm right here at term number 3. What do I do to term number 3 to get to term number 4? Well, I would have to add 4. So that's the recursive formula, and it would work all the way throughout this sequence. To calculate any term, you take the previous term and add 4. Now, there are limitations to using these recursive formulas. If we use the original formula, the arithmetic sequence formula, I could ask you to calculate the 98th term, and you're good to go. You can figure that out. If I ask you for the 98th term here, well, let's see what happens. Term 98 would be equal to term 97 plus 4. Well, wait, what's term 97? We don't know. And let's say we want to figure out term 97. Well, then you'd have to know what term 96 is. So that's the limitation, that you do have to know what the previous term is in order to get to the next one. So now we can do the same thing with a geometric sequence. So taking a look at this, 8, 24, 72. So we have an A value of 8, an R value of, looks like we are multiplying by 3. So my geometric sequence formula will be 8 times 3 to the power of n minus 1. Now again, we're going to come up with a recursive formula for this as well. So if we think about it, to calculate any term, what do we do? Well, how do I go from the 24 to the 72, or from the 8 to the 24? I take the previous term, so let's say term n minus 1, and what am I doing to it? Multiplying it by 3. So 3 times the previous term gives us the next term. That's our recursive formula. So again, limitation, you have to know what the previous term was. So I can't ask you for the 10th term because you'd have to know the 9th term. Now this next pattern right here, it's not arithmetic or geometric, but there is a pattern to it. So we're going to see if we can identify the pattern, and then we'll write our formula based off of that. So what we can do is we can start at the beginning. Well, how can we go from 5 to 14? Well, just writing out some rough work. This is not what I'd have as part of my solution. Let's say I take 5 and I multiply it by 2. Now that would give me 10. So then I'd have to add 4, and that gives me 14. Okay, so maybe that's our pattern, that we multiply by 2 and then add 4 from the previous term. Now, in order for this to work, that would mean that starting at 14, I now want to see if this works to get to 41. Well, multiply by 2 and then add 4, that's 28 plus 4, oh, that's 32. That's not what we want 41. So that pattern would work, multiplying by 2 and then adding 4. It does work for the first 2, but it doesn't work past that. So I'd like you to pause the video at this point, and I want you to try to determine what that pattern is, but it has to apply all the way through for all the numbers that we see here. And I'll show you the solution when you get back. Now, did you actually pause it and try to figure it out, or are you just waiting for me to do it? So what the pattern is, to figure out whatever term it is we're trying to do, we can take the previous term, but what we have to do is first multiply it by 3 and then subtract 1. Now this works if you take a look. So to calculate term 2, for example, it would be 3 times term 1, which is 5, minus 1, which is in fact 14. To figure out term 3 using that equation, it would be 3 times 14, which is 42, subtract 1, which is 41. So this is just how I'm checking. So by using the previous term, I multiply it by 3 and subtract 1, and there's our pattern. So it's just a matter of kind of trial and error and trying to figure out what that pattern is. Now, a special type of recursion formula, and this is kind of famous in math, it's called the Fibonacci sequence. Now, it's defined as if term 1 is equal to 1 and term 2 is equal to 1, then term n is equal to term n minus 1 plus term n minus 2. Now, we've been using n minus 1 as the previous term, so what n minus 2 would be is if you go back 2. So what this means, the first term is 1, the second term is 1, now we want to figure out what the third term is. So I'm going to do my work off to the side here. So in order to figure out term 3, that would be equal to, now term n minus 1 in this case would be term 2, and then plus term n minus 2, that's 2 terms back, is term 1. Now both of those in this case end up being 1 plus 1, so the next number is 2. And I'm going to erase this just so we don't have a huge mess. Now to figure out the next term, term number 4, n minus 1, the previous term is term 3, plus n minus 2 would be term 2, which is going 2 terms back. Now term 3 we just calculated as 2, plus term number 2, which is 1, the next value will be 3. Now I'll do one more with you, and then maybe you can try doing the rest of it yourself. So term number 5, n minus 1 would be term 4, plus n minus 2 would be term 3. We get, now term 4 we calculated as 3, plus term 3, which is 2, term 5 will be 5. So basically, we want to write out the first 8 terms. We don't have to show our work anymore. We basically just have to look and add up the 2 previous terms to get the next one. So 5 plus 3 is 8. 8 plus 5 is 13. And let's see, how many do we have? 1, 2, 3, 4, 5, 6, 7. We got to do one more. 13 plus 8 is 21. So we can keep going with this by adding up 21 and 13. That'd be our next number. But again, the limitation to this sort of thing is that we have to have the 2 previous terms to figure this out. So we wouldn't be able to figure out, for example, term number 18 without knowing 17 and 16.